Here's a project demonstrating an idea of using a motor sensor to control two motors through an input port on an NXT brick via I2C communications. I have 3 motor cards, each with 2 motors. Each card communicates to the brick using I2C and has a different address. The brick is running an NXTG program with a block I wrote to control the motor cards. Here is the card that I have created. This card has a jack that connects to the input port of a brick, an 8-bit processor for a microchip, a dual H-bridge driver that powers the motors. This card can drive the motor in forward, reverse, can coast to a stop, or brake. This card can also read back the optical encoders from each motor and send that information back to the brick. This particular card is set to address 66, and this is what the back of the card looks like. Each one of these NXT motors is just a standard NXT motor. I'm driving a large gear that has a pointer on it. Underneath there's a cam, and at a particular point it will depress a touch sensor. The way this works is when you first run the program, all the motors turn until they hit their touch sensors, then stop. This synchronizes them. Then they move to the set point output by the compass. When I turn the compass, the motors will turn to the new set point. In mode 2, the even number motors will turn in the opposite direction. This is done by subtracting the set point from the state of the motors. In mode 3, I add 100 to each consecutive motor. The first one turns as the compass turns, the second one turns plus 100, the last one turns plus 600. Here is a bolt I made demonstrating using 6 NXT motors on one brick. It has 3 steering motors connected to the output ports of the brick and 3 drive motors connected to 2 I2C NXT motor cards that I made. I am using a PlayStation paddle with Mind Sensor's wireless controller to control this synchro or omnidirectional bolt. And with programming, I can get this bolt to rotate. On the Mind Sensors and High Technics website, they used to have a card under development called a motor multiplexer. With this method, one could control up to 6 motors per brick, max. By using I2C on the input port, one could control more than 500 motors in theory. In reality, the NXT processor nor the I2C communications can handle that many motors, but 20 to 30 motors should work with no trouble.